With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, it is found that a neutron suffers a elastic collision with deuterium at rest. The fractional loss of its energy is Pd, while for the similar collision with carbon nucleus at rest, the fractional loss is Pc. You have to find out the value of them. So if you see, this is a neutron, right? Let's say the mass of one nucleon, mass of one proton or neutron is this. Nucleon is this. So let us say see what is the general loss in kinetic energy of this nucleon of this neutron after colliding with a nucleus having n nucleon, right? So it is let's say initially it was moving with velocity v, right? And after the collision, let's say it have velocity they two have velocity v1 and v2 after the collision, right? So here we will apply two equations. The first one is momentum conservation, and since the collision is elastic, then the velocity of separation will be equals to the velocity of approach, right? So momentum conservation, from momentum conservation we can see initial momentum was mv and final momentum was n. So what we'll do, we'll calculate the fractional loss in terms of the number of nucleon in this, and for deuteron the number of nucleon will be 2, and for carbon nucleus the number of nucleon will be 12. So that's why we are calculating this in terms of number of nucleon, right? So it will be, and if I write down the velocity of separation is equal to velocity of approach, so velocity of separation it will be this, by velocity of approach it will be equals to 1. Now if you see, this m will first of all get cancelled out, and you will get a equation this, right? Now we want this v1, right? If you see, we want this v1, so let's eliminate this v2. So for elimination, what we'll do, let's say this is equation 1 and this is equation 2. So what I will do, I will multiply this equation by n. I will write n v2 minus n v1 is equals to nv. Equation 1, equation 2. So if you will subtract the two equations, this n v2 will get cancelled out, right? So if you see, it will be this n v2 will get cancelled out, and it will be v1 plus 1 plus n v1, and here it will be, if you see, this is n minus 1 minus this, so it will be 1 minus n v, right? From here we'll get this v1, it will be equals to 1 minus n upon 1 plus n times of v, right? After solving these two equations, if we will get the final velocity of that neutron which was initially moving with the velocity v is this. Now if we wanted the fractional loss in kinetic energy, so if I calculate that fractional loss in kinetic energy, so final kinetic energy initial kinetic energy minus final kinetic energy, it will be, you can see, it will be half mv square initial one. Finally it is having velocity v1, and the initial kinetic energy was this. So if you divide them, I will write the loss, fractional loss, it is equals to this will be cancelled out by 1 minus this half m will get cancelled out. So I will write v1 by v whole square basically. So v1 by v you could already see it is 1 minus n by 1 plus n, right? So put the value here. So I will write 1 minus, it is 1 minus n upon 1 plus n whole square, right? So now you can put the value to get the fractional loss, right? For deuteron, I will put the value of n is equals to 2. So if I put the value of n is equals to 2, it will be 1 minus 2 upon 1 plus 2. It will be 1 by 3 whole square, so it will be 1 by 9. So it is 8 by 9, right? So for deuteron, I can write the loss is 0.89. This will be 0.89. Now for carbon 12 nucleus, just replace this n by and put the value of n is equals to 12. So for carbon nucleus, the n will be equals to 12. So for here I will write 1 minus 12 upon 1 plus 12. So it will be square here. So I will write 1. So it will be 11 by 30 whole square. We are calculating the fractional loss, right? So it will be 1 minus 121 by 169. So it will be 169 minus 11 square, that is 121 by this. So 169 minus 21, it will be 48. In division, it will be this. So this will be the fractional loss in case of the carbon nucleus. Now you can see the answer, right? So in case of hydrogen, it is 8 by 9. In case of carbon, it is 48 by 169, right? So if you move toward the option, so yes, C is the correct answer, since 48 by 169, it is 0.28, right? Simple. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.